Hello, and welcome back to the channel. So let's do one more example on illustration of areas given by a following Riemann sum. So we'll follow the same steps that we discussed in the last video. So if you have not watched the previous video, I would highly suggest you to first watch the previous video in order to get the full context of the steps that we'll be doing or the steps that we'll be following in this video. So we have a similar question again. We have been given a sigma notation for a Riemann sum, and based on the Riemann sum we have to identify the function fx, and after identifying the function fx and the intervals for which the area under the curve is bounded, we'll sketch the graph of the function and illustrate whether it's a left hand Riemann sum or a right hand Riemann sum based on the interpretations that we'll do. So let's get started. In order to solve this question, I'll first write the prototypes of what a Riemann sum looks like, and based on the pattern of this question, I observe that I have an I minus 1 term. So it sort of gives me an idea that it's better for me to use this expression, which is the expression for a left hand Riemann sum. So I'll write the prototype for a left hand Riemann sum now, which is sigma I goes from 1 to n. I have my function fxi and delta x, where my xi is basically a plus I minus 1 delta x, and my delta x is b minus a by n. And if I again compare both of these sigma notations, I can easily see that my n is equal to 5, my delta x is equal to pi by 20, and if I relate this expression to this expression, I can clearly see that I minus 1 matches with I minus 1, my delta x is pi by 20, which indeed matches with pi by 20, so I have this expression, but I don't have an a. So this gives me an idea that in this case my a is 0. So I'll write my a, which is equal to 0 in this case. So now I have my n, which is equal to 5, I have my a, and I have my delta x as well. And now I'll just solve for my b. So I know my delta x is equal to b minus a divided by n, which is equal to b minus 0 divided by n. And I also know from the above expression that my delta x is pi by 20 and my n is 5. So I'll substitute both of these values. Delta x is pi by 20, b minus 0 will become b, and n is 5. So my b becomes 5 pi by 20 or pi by 4. So now I have everything sorted out. I have my b, which is my right endpoint. I have my a, which is my left endpoint. I also have the number of subintervals or the number of rectangles that are used for the approximation of area. So based on all this given information, and I also know that I'm using a left hand Riemann sum instead of right hand Riemann sum. So based on all this given information, now I have to replace my occurrence of a plus I minus 1 delta x, which is indeed I minus 1 delta x because my a is equal to 0. Now my last step is to replace every occurrence of a plus I minus 1 delta x and change it to x in order to get my fx. So now since I have everything calculated, I'll just replace my every occurrence of a plus I minus 1 times delta x and change it to x in order to get my function. And I clearly see that in my case a is equal to 0 and my xi will then become I minus 1, my delta x is pi by 20, which is again this expression. So now in order to get the function, I'll replace this occurrence with just x in order to get my function. So after doing everything, my function will become sigma I equals 1 to 5 tan x delta x. And this result can also be confirmed by substituting all the values back again in order to get this Riemann sum again. So now I got my function fx, which is tan x, and I know I'm approximating the area under the curve for y equals tan x between the endpoints a equals 0 and b equals 5 pi by 20 by taking 5 rectangles and using left hand Riemann sum. So now since I have all the information, it's easier for me to sketch the curve, which would look like this. So I'm approximating the area under the curve for y equals tan x starting from a equals 0 to b equals 5 pi by 20, and you will realize one more thing, that there are indeed 5 rectangles in this case because my n is equal to 5, but the first rectangle of the 5 is a trivial rectangle with height and area equal to 0. Because if I substitute f0, or if I calculate the height of my first rectangle, it would be f of 0, which would be tan of 0, which is 0. So that is why I have my first rectangle, but my first rectangle is a trivial rectangle with height 0. So that was it for today's video. I hope you found this video interesting. Please follow the channel in order to get notified about the other videos that I'll be uploading. Thank you so much for watching. Stay tuned. Bye bye.